Hey everyone, today we're going to discuss about exponential and logarithmic inequalities. So for our lesson today, we will be solving solution sets involving exponential and logarithmic inequalities. So, an exponential inequality is an inequality involving exponential expressions, while a logarithmic inequality is an inequality that involves logarithm. An example of an exponential inequality is like this: 2 raised to x is greater than 4. So we are going to solve with the solution set the values of x's that when replaced in this inequality would make this inequality true. So that's an example of an exponential inequality. Moreover, if we have a logarithmic inequality, it can be like this: logarithm of x to the base 2 is less than 10. This is an example of a logarithmic inequality. So logarithm of x to the base 2 is less than 10. Okay, let's have some properties of exponentials and logarithmic inequalities. This will be very essential later when we try to solve for the solution set of the exponential and logarithmic inequalities. Number 1, we have b raised to x is greater than b raised to y if and only if x is greater than y. So this is similar with the one-to-one property where if two bases are equal, then the exponents are equal. In this scenario, if one exponential expression, b raised to x, is greater than the other, but their bases are the same, then it means that their exponents hold the same relationship. X is greater than y. That is also true when the symbol is also less than, and that's the second property. If b raised to x is less than b raised to y, if and only if x is less than y. So that statement is also true. For the third property, we have logarithm of x to the base b is greater than n, then this means that x is greater than b raised to n. So this relationship holds true for any logarithmic inequality. And this also works even if the symbol is less than. And take note of the position because the position here matters since this is an inequality. It isn't like an equation where the left side and the right side are equal. In this case, the left side and the right side are not equal, so we have to pay attention on how it is written and where is it located in the inequality sign. Okay, let's have an example here. We have here number 1, 32 is greater than 2 raised to 2x plus 1. Solving exponential and logarithmic inequalities share some similarities with solving exponential and logarithmic equations. We just have to apply the properties mentioned earlier. So we have here a 32 which is greater than 2 raised to 2x plus 1. If you've noticed, 32 is actually an expression which we can write as 2 raised to something. And take note, 32 is actually 2 raised to the 5th power. So we can rewrite 32 as 2 raised to the 5th power is greater than 2 raised to 2x plus 1. And take note that they have the same base but different exponents, and they're separated with a greater sign symbol. So using the first property, we may say that 5 is greater than 2x plus 1. From here, we can solve for the value of x. It's much better if we flip the left and the right side so that we can have the variable on the left side. It's much nicer if we do it that way. 2x plus 1 is less than 5. Note that if we flip the left and the right side, the inequality symbol also flips. So we transpose the 1 to the other side, subtract both sides by 1. We'll have 2x is less than 4. Then, we divide both sides by 2. This gets divided. So we will have x is less than 2, since 4 divided by 2 is 2. Therefore, the values of x that we're going to have are those values from 2 going down, well, not including 2. So the solution set will be from negative infinity up to 2. But 2 is not included, so there will be a parenthesis. So this is our solution set, from negative infinity up to 2, not including 2. Let's have this next example here. We have the logarithm of x plus 3 to the base 2 is less than 4. Now, before we try to solve this, let us remember one very important thing about logarithm. This concerns about the argument of the logarithm. Take note that the argument of a logarithm cannot be negative. It cannot be 0 as well. So it should be a positive number only. So before we solve this, we should take that consideration first. We have to have x plus 3 is greater than 0. We have to know the values of x's first. That will ensure that this argument here will be a positive number. So that's what we have to do first before we solve for the logarithmic inequality. So we have x plus 3 is greater than 0 because the argument cannot be equal to 0 nor less than that. So this means that x is greater than negative 3. So the values of x's should be from negative 3 going up, not including negative 3. We will use this later when we have our solution set. So this is our first solution set that we have, which concerns the property of the argument. Now, in solving for logarithm of x plus 3 to the base 2 is less than 4, we will be applying the third property mentioned earlier, that is log of x to the base b is greater than n if and only if x is greater than b raised to n. So what we're going to do here is we write the argument x plus 3 is less than, on the right side we have the base and the exponent 4. So x plus 3 is less than 2 raised to the 4th power. So we'll have x plus 3 is less than 2 raised to the 4th power is 16. Transpose 3 to the other side, we will have x is less than 16 minus 3, that is 13. So we have this solution set here, x is less than 13. So the values of x's will be from 13 going down, but remember not including 13. However, let's remember that we have another solution set here, which is x is greater than negative 3. So combining them together, this means that the value of x should be lower than 13 but greater than 3. So x is less than 13 but greater than negative 3. So it's in between negative 3 to 13. Therefore, the solution set is from negative 3 up to 13. Let us remember that there's always a case like this. The argument cannot be 0, it cannot be negative. So that's everything about exponential and logarithmic inequalities. I hope you guys learned a lot today. Thank you guys for watching and see you guys on the next video.